Now that we've set up our basic formalism for talking about group decision-making methods, the next task is to try to start formalizing some of the basic principles of group decision-making method and then use those principles to characterize different voting procedures. So we're going to start in this lecture with three principles: anonymity, neutrality, and unanimity. So starting with anonymity. Recall that a group decision-making method is just going to be some function from a domain of profiles to some ordering over the set of candidates. Now, I'm trying to be as general as possible. So we're not going to focus on linear orderings. Rather, we're going to focus on a more general setting where we just have reflexive and transitive orderings over the set of candidates. And D is just some arbitrary collection of profiles. So this is what our group decision-making method is. It's a function that associates to some domain, to each profile in the domain, some reflexive and transitive ordering over the set of candidates. Now, informally, anonymity means the outcome of the function should not actually depend on the names of the voters. So how are we going to formalize that? How are we going to make that more precise? Well, to do that, let pi be essentially a shuffling of the voters in the set n. So pi is going to be a permutation. It's a one-to-one and onto map that maps elements of n to itself. And for a particular profile, let pi of that profile be the corresponding shuffling of all of the orderings in the profile. So for example, just to fix the idea, suppose n, we have three voters, 1, 2, and 3. And we do a shuffling where we swap 1 with 3. We shuffle 1 and 3. So let pi of 1 gets mapped to 3, pi of 3 gets mapped to 1, and then agent 2's name remains fixed. So if we have some profile, R1, R2, and R3, shuffling that profile gives us R pi of 1, R pi of 2, R pi of 3, which is actually equal to then R3, R2, R1. So all we're doing is we're taking the ordering in the first component of the profile and swapping it with the ordering in the third component of the profile. Now, what anonymity says is just simply, so our group decision-making function satisfies anonymity if for any permutation of the set of voters and for all profiles, the ordering associated with that profile doesn't depend on the particular shuffling. So we have some ordering associated with a profile R, and we have any way of shuffling around the names of the voters, the outcome should be exactly the same. So that's anonymity. And now neutrality is a very similar idea. Recall that informally, neutrality just means the outcome does not depend on the names of the candidates. So we can formalize that in much the same way. Suppose pi is a permutation on the set of candidates. It's a one-to-one and onto function from x to itself. Now, if I fix an arbitrary ranking or arbitrary ordering over the set of candidates x, let's let R pi be a new ordering that's defined as follows. A is going to be R pi related to B if and only if C is related to D and C gets mapped to A and D gets mapped to B. So, for example, suppose X contains 3 candidates, A, B, and C, and we have some permutation of the names of the candidates. So pi of A is equal to C, pi of C is equal to A, and then pi of B just remains fixed. Then if we have some ordering, let's say R, such that A is related to C, if A is related to C, then under the permutation, it's going to mean that C is going to be R pi related to A, because A is related to C under the original relation, and then when you apply the permutation on the set of candidates, that means that C must be R pi related to A. So if we have a profile R, let R, boldface R to the pi, denote the orderings R sub 1 to the pi, R sub 2 to the pi, and so on. Now, neutrality just means for all permutations pi on the set of candidates, if I first permute the candidates in each of the relations, or in each relation in the profile, and determine what ranking is associated with that new profile, that should be exactly the same as first trying to figure out which ordering is associated with the original profile, and then permute all of the candidates. So that's what neutrality is. And finally, we have Pareto, or unanimity. Recall that Pareto means never elect a candidate that's strictly dominated. So the way we're going to formalize that, so recall this notation, NR of APB, that means that that's the set of voters that rank A strictly above candidate B. If that set of voters is equal to everyone, to the whole set of voters, then that just means everybody ranks A ahead of B. And if that's the case, Pareto means if everybody ranks A above B, then it cannot be the case that society or the group outcome ranks B ahead of A. So here, P is the strict subrelation associated with F of R. So F of R is the group ordering, reflexive and transitive ordering, associated with the profile R. So what the definition of Pareto, or weak Pareto, says, if everybody ranks A strictly ahead of B, then B cannot be socially ranked strictly ahead of A. Now, in the context when the range of our group decision-making method is just is the set of linear orderings, if B cannot be ranked strictly ahead of A, that means A has to be ranked strictly ahead of B. So we can simplify the definition of Pareto a bit and say if everybody ranks A ahead of B, then society has to rank A strictly ahead of B.